Welcome to my channel Elite Maths class. Today's topic is second order derivatives. In my last few videos I have already discussed first order derivatives and different methods of first order derivatives. There are actually 5 methods. Different methods are discussed. You first go through the, if you are watching this video first time, you first go through that different methods already discussed, whose links are given in the description box. Now today's topic is second order derivative. This is a topic of class 12. It is a part of derivatives and it is actually the last part of derivatives. So before starting second order derivative, we first remind some concepts of first order derivatives. Y equal to fx, we know y equal to fx means y is a function of x. Now what is first order derivative? Up to this only derivatives etc. are discussed. The order of the derivative or differentiation was not mentioned because we were studying only derivatives. Now in derivative we have seen that when y equal to fx, that is any function of x is given, then we have to find the differentiate of y with respect to x. Now that means we are differentiating y for one time only. We are differentiating y once. That is, one time derivative of y is called first order derivative. Clear? That is, when y equal to fx is a function of x, then dy by dx, this is already known to you. Dy by dx means derivative of y with respect to x. Is dy by dx is called derivative of y with respect to x. It is also called differential coefficient of y with respect to x. Differential coefficient of y with respect to x, not necessarily always with respect to x. Say if y is a function of t, then here it will be dy by dt, that is derivative of y with respect to t, or differential coefficient of y with respect to t, whatever variable, dependent variable is there. It is called the first order derivative of y with respect to x. First order means only once, that is one time derivative of y. It is called first order derivative. Here different notations are here for first order derivative. One is f dash x. Dy by dx, when y is a function of x, it is denoted by f dash or f prime x. It is also denoted by y suffix 1. It is also denoted by y prime. It is also denoted by capital D y. D not suffix, D into y, capital D y. Here capital D stands for d by dx. It is called differential. It is called differential operator. In the higher topics you will get this one. So there are total 5 different notations. Dy by dx, you may also write f dash x, you may also write y1, you may also write y prime or y dash, capital dy. In some cases, especially in your physics, in many chapters you will get y dash x dash. Here y dash x dash also denotes the first order derivatives, but particularly when the derivative is with respect to t means time, then these first order derivatives are denoted by dot. This is the concept of first order derivative. Now let us see what is second order derivative. As I have told earlier that dy by dx means one time derivative of y, that is y is differentiated only once. Now the same y can be differentiated twice. Say y is given anything, then we find dy by dx. Now the derivative of dy by dx, that is when y is differentiated twice, this value is called second order derivative of y with respect to x. That is 2 time derivative of the given function, 2 time derivative of y, that is twice differentiation of y is called second order derivative. That means second order derivative is nothing but derivative of derivative. Now see, what does it mean? Say y equal to fx is a function of x, then what is dy by dx? Dy by dx is d dx of, that is derivative of fx. It is first order derivative. Okay, Now what is second order derivative? Second order derivative means again derivative of this function or again derivative of this function. So as derivative of y is written as ddx of y, so we can write that it is ddx of dy by dx. See this part, dy dx is first time or once derivative of dy by dx. Here we are taking again derivative of dy by dx. Here also it will be ddx of fx. Now how to denote this, or what is the notation of this? This is written as d2y by dx square. This is the notation of second order derivative. These two or squares, this indicates here the second order derivative of y with respect to the variable x. It is also written as d2x square by d2 by dx square fx. So what is d2y by dx square? Ultimately this is the most important relation. d2y by dx square is ddx of dy by dx. That is, now what is dy by dx? dy by dx is first order derivative of y or one time derivative of y, then that value is to be differentiated again with respect to x. This is called second order derivatives. The other notations of d2y by dx square are, it is also written as f dash x. These are other notations. It is also written as f dash. See, f dash x denotes first order derivative, so it will be f double dash or f double prime x. Another notation is, it was y1 for the first order derivative, it will be y2. Third one is y double prime or y double dash, or the last notation is capital D square y, where capital D square stands for d2 by dx square. This is also the differential operator. So this is the main concept of second order derivative. Nothing new, only as the first order derivative is known to you, so the second order derivative means twice differentiation of the given function. That is, we have to differentiate two times of the given function or the given variable or whatever it is given. So this is the formula d2y by dx square. This is the notation f double dash x or y suffix 2 or y double prime or capital D square y. This is the concept. Now for problem or exercise point of view, what types of question are asked? For exam point of view, you will definitely in your board exam 1 or 2 questions or 1 or 2 short questions will be there, definitely will be there. One question of 4 marks we can expect, or definitely there will be there. Or in different entrance exams, especially JEE mains or other entrance exam, question of derivative are frequently asked. Basically they are the questions of differentiability. In a different video I will discuss that differentiability and continuity. In entrance point of view, these type of questions are very important, differentiability and continuity. This type of questions also, that is direct differentiation, are also asked. And another important thing, these type of derivative are called total derivatives. These are called total derivatives. Actually in the whole class 12 syllabus all the derivatives are total derivatives. In the higher classes we see many different types of differentiation are also there. Now let us see very simple 2 examples how to find the second order derivative of a given function. For example, let us see the first example. Say y equal to see the very simple one, y equal to x power 4 is given. Find dy by d2y by dx square. That is, we are asked to find second order derivative of the given function y equal to x power 4. Mind it, definitely the before second order derivative first order derivative comes, so without finding the first order derivative we can't find the second order derivative. So before finding d2y by dx square we must have to find first order derivative. So here what is dy by dx? dy by dx is ddx of x power 4 means 4x cube. Therefore, now we are to finding d2y by dx square. d2y by dx square means ddx of what? ddx of dy by dx. That is the twice differentiation of y, or the second time derivative of y. So what is dy by dx? Already obtained. It is 4x cube. Now 4 is a constant, so 4 will be out of ddx into ddx of x cube. Now what is ddx of x cube? It is 3x square. So the final answer is 12x square. This one is very simple, just to explain the process. Now see another one. So y equal to x e power 2x. Find y2. You are asked to find y2. Now remember that what is y2? y2 is d2y by dx square, nothing but the second order derivative. So as usual, first we have to find, you always write in the first step, differentiating with respect to x. So it will be dy by dx. dy by dx equal to what? ddx of x into e power 2x. Now which formula to apply here? It is two function, product of two function, x into e power 2x. So definitely it will be u into v. So what is the formula of u into v? It is u ddx of v plus v ddx of u. So what we are getting? X e power mx. Formula of ddx of e power mx. ddx of e power mx is m into e power mx. Remember the formula, m into e power mx. So an extra 2 will be here. M, this is m into e power mx plus e power 2x into ddx of x 1. So we have obtained dy by dx. Next part is we have to find, therefore d2y by dx square is ddx of this part, that is ddx of this one. Now ddx can be separated term by term plus ddx of e power 2x. So d2y by dx square is, here again 2 is a constant, we can write 2 here. This here again u into v. Now here apply a technique, ddx of x e power 2x. This is same as the value of the first derivative. So value of this will be this one, whole one, 2x e power 2x plus e power 2x. Now this one is the extra term, ddx of e power 2x. It will be 2 into e power 2x. This formula, m into e power mx. This is equal to 4x e power 2x plus 2 plus 2. 4 into e power 2x. You can take 4 e power 2x common. It will be x plus 1. Now see this example. In this example, this is a proof type question, that is show that. See the question, y equal to tan inverse x whole square, show that 1 plus x square whole square d2y by dx square plus 2x into 1 plus x square dy by dx minus 2 equal to 0. This is the second type of questions of derivative, second order derivative, that is prove that type, show that type. For this type of questions there are two methods. That is, one is in general method, simply y is given, find dy by dx, then differentiate the value of the dy by dx, then take the LHS. In LHS put the value of dy by dx, d2y by dx square, then simplify, and then show that this is equal to RHS. That is, show that LHS is equal to RHS. But I am showing the this one is very simple process. If you can't find the technique, then simply find the derivatives. That is, first find dy by dx, d2y by dx square, put in the LHS, show that LHS is equal to RHS. Now what technique you have to use, or you must use? If you use these techniques, then the question will be, the process solution will be shorter. That is, in very short way you can solve the problem. Now if y equal to tan inverse x, then definitely the first thing we have to find out the value of dy by dx. Given is what? Y equal to tan inverse x whole square. First differentiate with respect to x. So we are getting dy by dx. dy by dx is what? ddx of tan inverse x whole square. Here As I have discussed in my earlier videos, this one, to find ddx of tan inverse x whole square, we have to use chain rule or the method 1. See here, it is ddx of tan inverse x whole square. Consider tan inverse x as x, so it is like ddx of x square. Now what is the value of ddx of x square? It is 2x, so it will be 2 into tan inverse x. That is, we have considered tan inverse x as x, so we have to multiply the value of derivative of tan inverse x. So what we are getting? 2 tan inverse x into 1 by 1 plus x square, that is equal to 2 tan inverse x by 1 plus x square dy by dx equal to. So the value of first order derivative we got. Now we have to prove this part. Now say dy by dx is this. From here you can differentiate again by using u by v. You will get the value of dy by dx square, then take LHS, put here and here, then simplify. This is the general method or the easier method. Now what technique I was talking? See, whenever these type of questions are asked, then if the value of dy by dx is in the form p by q, that is, if in the denominator part any expression is there, then what we will do? See, this one is very important technique. In most of the problems we have to use for this type of problems. Now the technique is, this part of the denominator you multiply in LHS part. So we are getting 1 plus x square into dy by dx equal to 2 tan inverse x. After doing this, then you see what is y. What is y? Y is tan inverse x whole square. See, in the RHS part it is tan inverse x only. If it is tan inverse x whole square, then we can put y. So here the next technique is square both sides. 1 plus x square whole square, we will be getting dy by dx whole square equal to, it will be 4 tan inverse x whole square. Without this technique, without squaring, you can also solve the problem. So this is the technique. In some of the cases, actually in some of the questions, now see the next step. I am coming to that point. Dy by dx whole square equal to 4. Now see, tan inverse x whole square is what? Y. It is given in the question, since y equal to tan inverse x whole square. Without squaring, I was talking about this. Without squaring, you can also prove this one. Now what is the benefit of squaring? In some of the questions you may ask, if y equal to tan inverse x whole square, then prove that this, hence prove that this. Clear? There will be two parts of the question. First, prove this part. The question will be like this, hence part. That is, after proving this, you have to prove the last part from this equation, from this relation. Now see, this one is done. Now what to do? Again differentiate with respect to x. So what will be there? It will be ddx of 1 plus x square whole square dy by dx whole square equal to 4 is a constant, 4 into ddx of y. Now what will be the next step? Here see, another two functions are there, u into v. So we apply u into v, 1 plus x square whole square into ddx of dy by dx whole square plus dy by dx whole square into ddx of 1 plus x square whole square equal to 4. ddx of y means dy by dx. Now see the next step, 1 plus x square whole square. Here again ddx of dy by dx whole square, again apply the chain rule. Consider dy by dx as x, so ddx of x square is what? 2x. So it will be 2 dy by dx into whatever is considered as x, multiply ddx of that part, that is ddx of dy by dx. So this is clear. Now here dy by dx whole square, here again chain rule, ddx of x square 2x, 2 into 1 plus x square into ddx of 1 plus x square equal to 4 dy by dx. 1 plus x square whole square 2 dy by dx. Now ddx of dy by dx is what? It is d2y by dx square plus 2 1 plus x square dy by dx whole square into what is ddx of 1 plus x square? ddx of 1 is 0, x square 2x equal to 4 dy by dx. Now say we can take common, 2 is common, dy by dx is common, so we take 2 dy by dx common. What remains? 1 plus x square whole square d2y by dx square plus 2 common, another 2 is there, 2x, 1 plus x square, 1 dy by dx common, another term will be there, this is equal to 4 dy by dx. This dy by dx cancelled, 4 can cut by 2, 2 will be there, so what remains? 1 plus x square d2y by dx square, 1 plus x square whole square plus 2x into 1 plus x square dy by dx. What remains there? Only 2, it will be minus 2 equal to 0. This is the proof. So by applying technique, another way I already told, by finding the differentiation separately, take the LHS, put the values and simplify, you will also get the result. But this is the technique, and if the question is asked in a way that the first part is there, if y equal to tan inverse x whole square, prove that this part, first order differentiation relation, hence prove that this one, then you have to go by this way only. And another thing is, by applying this technique, most of the problems will be very shorter, that is very easily you can prove or you can solve by saving your time. So hope second order derivative, concept of second order derivative and this technique is also clear to you. Go through the examples and exercise of your book NCERT, or you may see R.S. Agarwal or R.D. Sharma. In R.D. Sharma there are lots of problems, varieties of problems. You solve this, try this. Hope this was very helpful for you. Thank you very much.